Let us do now some examples where we have a composition of more than two functions. For instance, this one, f of x, which is the sine of the exponential of x squared plus 1. This one is the composition of three functions, the sine of x, the exponential of x, and then the last one we could say x squared plus 1. Okay, just to keep it simple. Written like this, f of x is lowercase f of g of h of x, and then close all the parentheses. Or we could write h composed with j composed with f. It's the same. Let's create some space here. Okay, so the derivative, if we wish, we can write the general formula. It will be the derivative of f evaluated in everything that is inside times the derivative of g evaluated in everything that is inside times the derivative of what is inside. Okay, this is a general format, but we don't do it like that. We just go ahead and do it in the particular case. So the formula, the function that is outside is the sine, right? So the derivative is the cosine. Cosine of the exponential of x squared plus 1 times the derivative of the exponential, which is itself evaluated in x squared plus 1, times the derivative of the last one, x squared plus 1, which is 2x. And this is the final result. Okay, maybe this was a little fast. Let's do more examples. Let's say we have the function f of x, which is the sine of the cosine of the tangent of x. Okay, so the derivative is going to be the derivative of the cosine, of the sine, which is the cosine evaluated in the cosine of the tangent of x, times the derivative of what was inside, the cosine of the tangent of x. This is the cosine of the tangent of x times the derivative of the cosine, which is negative sine of the tangent of x, times the derivative of the tangent, and this is the cosine of the tangent of x. Let's put the minus in front of everything, times the sine of the tangent, times the derivative of the tangent, which is the secant square, or 1 plus the tangent square, as you prefer. And this is the final result. Let's see more examples. You can pause the video after I state every example and try by yourself and then compare. So this is 3x exponential of sine of x squared. What do we have here? So this is a combination of everything together, right? Because we have a product rule clearly, but then, sorry about that, we have the product of two things, but then the second part of the product, the second factor, is a composition of three functions, the exponential, the sine, and x squared. So the derivative is product rule, derivative of the first times the second plus the first times the derivative of the second. Now, you can decide if you want to compute this derivative on the side and then plug the result back in, or carry all the terms all the time. It's up to you. Sometimes it's easy to make a mistake if we carry all the terms all the time, we end up forgetting something. So it may pay off to do it on the side, okay? But in this case is the derivative of the outside function, the exponential, evaluated in the sine of x squared times the derivative of the inside, which is a sine. So we have a cosine of x squared times the derivative of the innermost function, which is the derivative of x squared 2x. Okay. So here, just to be clear, this is the derivative of the sine of x squared. Sorry, the whole thing here is the derivative of the sine of x squared. There we go. And here we can simplify a little. We have 3 plus 6x squared times the exponential of sine of x squared. So I'm factoring out the exponential of the sine of x squared. And I think this is as nice as we can write it. And let's do one more example just to round it up. We have f of x. Let's do something more difficult with the second of the square root of the sine of the exponential of x to the power 3 plus 3x. How about that? Now is a good time to pause the video and try by yourself. So what is the derivative? So the derivative of the second, remember, is, if you don't remember, you can always compute it. The second of x is the second times the tangent. Okay, so this is the second of the whole thing times the tangent of the whole thing, okay, times, I need some space there, times the derivative respect to x of that square root of the sine and so on. Okay, so it's kind of long. All right, so the first part, we are not going to do anything with it, so we can just copy paste. And for the second part is the square root, right? So the derivative of the square root is 1 divided by twice the square root of sine of the exponential of x to the power 3 plus 3x times the derivative of what is inside, which is the cosine of the exponential of x to the power 3 plus 3x. Okay. I think I'm going to like this better. It will be more clear if I do just one step at a time, even if it takes me a little longer. But it's the derivative of the square root times the derivative of what was inside of the square root. Now, let's copy paste. Let's expand this derivative of the sine. So the derivative of the sine is the cosine of what was inside, which I could have recycled from before, but anyway, times the derivative of the exponential of x to the power 3 plus 3x. And then we're almost there. Copy paste. We only need to expand this last derivative because it's the the exponential is, let's just finish now. Because it's the exponential, the derivative of the exponential is itself. And then we need to write the derivative of x to the power 3 plus 3x. But this is 3x squared plus 3. So let's just put it here. Okay. And be done with it. It's just to be clear, this is the derivative ddx exponential of x to the power 3 plus 3x. Okay. And this little monster here is the derivative we were looking for.